so let's talk about some characteristics of my molecular compounds. So remember, molecular compounds are those that do covalent bonding, that do the sharing. So molecular compounds have low melting and boiling points. So they're going to have low melting and boiling points. And when I say low, it's generally going to be less than about 300 degrees Celsius. So that's kind of what I mean by low. Now this should be completely different than ionic, because ionic compounds had very high melting and boiling points. So they're the opposite, molecular or low. Molecular compounds are found in all three states at room temperature. It doesn't mean that one compound is going to be in all three. It's saying that I can find an example of a solid, example of a liquid, and a solid of a gas that is at one of those states at room temperature. Okay? Now, when I'm changing my phase, when I'm either melting or boiling something, what's happening is I'm breaking the attractions between the molecules, not the bonds themselves. So I'm going to show you a picture on the next slide that kind of helps you. So this is the molecule itself. Okay? So here I've got some pentane. So this is pentane, which you don't have to know that. But here's my molecule. It's got C's and H's, so it's two nonmetals. So if it's all nonmetals, it's a molecular compound. So I have a molecular compound. So this has bonds in it. They're sharing the electrons. Okay? And then there's attractions between this compound and the next compound. That's what these little dots mean. These are attractions. So whenever I'm boiling something or melting something, what I'm doing is I'm breaking these little attractions between the molecules. These attractions are called intermolecular forces, which there's a whole chapter we're going to talk about what they are and what the different types are next semester. But these attractions are weak. So it's weak. We have weak attractions between the molecules. Within the molecules, these are bonds. Okay? So these are weak forces and attractions. These are bonds, which are really strong. So within the molecule, these are strong bonds. So whenever I'm melting or boiling something, I'm not breaking apart the molecule. Look, it goes from a liquid to a gas, he's still together. I'm breaking apart these attractions. Now there's no attractions. So that's what this is saying. Melting and boiling involve the breaking of the attractions between the molecules, not the bonds. Okay? We're not breaking the bonds. These bonds are very strong. The attractions are weak. So bonds strong, attractions are weak. Okay? So we're going to break these attractions. Now, the strength of these attractions depends on what type of bonds these are, what type of molecules, all that. And we'll get into that later. Okay? But they're always going to be weaker than the bonds themselves. All right, a little bit more characteristics. Molecular solids, they can either be brittle and hard or soft and waxy. So we have a lot of diversity in my molecular compounds. All right, just to reiterate, the kind and strength of those attractions varies based on many factors. The bonds are not broken, we're only breaking those attractive forces. Okay, really stressing that. Now let's talk about conductivity. Are they going to conduct electricity? So remember we talked about this before. To conduct electricity, I have to have two things. I have to have charged particles, and then I have to be able to flow. Those are the two things I need. To conduct electricity, I have to have charged particles, and I have to be able to float. So let's talk about molecular compounds. Are they going to have charged particles? So let's think about water. Okay. So actually, let me give you a different example. Water is a really funky exception to the rule. So let's look at this guy. Actually, this will be easier. So let's look at him. He's a molecular compound. When I show his picture, do I see any charges? Do I see any charges when I show you the picture? No, because he doesn't exist in them. Now remember when we had NaCl. When we looked at his picture, there was like a positive one, and then right next to it was a negative, and then there was a positive, and then there was a negative, right? They had their charges still. That's what kept them together. Here, molecular compounds, they don't have charges. So they have no charged particles. So even if it's a solid, it for sure can't do it because it can't flow. But if I were to take the solid and dissolve it in water, it's still not going to conduct electricity. So molecular compounds do not conduct electricity even in the liquid state. Even in the liquid state. So molecular compounds do not conduct electricity even if they're in the liquid state because there's no charged particles. There's one exception. This is the exception. Acids. Okay? Molecular acids, they do what we call ionize. So ionize means that they're going to break apart into ions. So if it is an acid, then it will break apart into ions when it is dissolved in water. So molecular acids do conduct electricity when they're dissolved in water, but not if they're in the solid state, because you still have to be able to flow. So the acids, when I dump them into water, they're going to ionize. They're able to break apart, and because they can break apart when they're dissolved, they'll have the charges then, and because they're in water, they'll be able to flow. So the only thing that can conduct electricity out of anything that does covalent bonding is a molecular acid. Now you might say, well, how do I know if it's a molecular acid? We're going to get there, okay? We're not going to cover acids in this chapter, but we will cover them this semester, okay? So for now, just keep that in the back burner that it's not that all molecular compounds do not. There is the exception of acids, okay? And so for an example, molecular compounds could be F2, it could be our pentane, which was our C5H12, any of those. Molecular acid ends up being like HF or HCl, etc. And we're going to talk about how do you know that that's an acid compared to just a molecular compound later on. Alright, so now let's move to the last part of the naming section of part one of chapter 4. So now that we know about molecular compounds, now we want to talk about, well, how do I name molecular compounds? That's what we're going to do in the next chapter. Next lecture.